Okay, lecture 21, we're going to talk about solving quadratic and rational inequalities. So inequalities meaning that you're going to have greater than, less than or equal to, greater than or equal to signs there. Quadratics, your quadratics are going to be something in the form of x squared minus x minus 12. And since it's an inequality, it's going to be greater than 0. Okay, if I'm talking about rational, rational is ratios, meaning fractions. Going to be something like this, less than or equal to 0. Okay, so how do we deal with those? We never solved them with inequalities before. How do we do it? We're going to do it with split point method. Okay, so starting out within our first video, quadratic inequalities. They all have a standard form. What is their standard form? Well, just like quadratics, you have to make sure that it equals 0. Except since we're talking about inequalities, it won't equal 0. It'll be less than 0, greater than 0, less than or equal to, greater than or equal to 0. But just like with our quadratics, it has to have a 0 on either the right or the left. It doesn't matter which side. But it has to have a 0 in order for us to figure out and solve for our answer. Okay? Now, what do our quadratic equations look like? Well, remember, they are going to be, say, something that looks like this. Maybe a parabola's been shifted down 4 spots, like so. Okay, parabolas could also be shifted left or right. Now, left, right, up, and remember they could also be flipped as well. So you could have something that looks like this. Okay, now, the types of questions that they are going to ask you guys is they're going to say, okay, x squared plus 2x minus 8 is greater than 0. Okay, so they're going to be saying, hey, you got this function, f of x. When is that function greater than 0? Well, that should look familiar from exam 3 when we would answer those questions there. Remember, f of x is interchangeable with y. So the question they're asking is, when is your y greater than or equal to 0? Well, our y values are greater than or equal to 0 up on the top part of that, right? So for this function here in red, when is this function greater than 0? Well, that part of the function is greater than 0. And that part of the function is greater than 0, right? So our answer for this, based on looking at the graph, we would say, well, it's from negative infinity to negative 2 in union with 2 to infinity. So from negative infinity all the way to 2, and then from 2 all the way to infinity would be our answer for that. That's when our function is greater than 0. Okay? So one of your answers that you're going to get with dealing with the quadratic is going to be an unbounded. Okay? Meaning it's going off in both directions. If we look at our green function, and we are like, hey, okay, when is f of x greater than 0? Well, this section right here would be the part where it was greater than 0, right? So this is going to end up giving us a bounded interval. We would say from negative 4 to 0. Okay? Some other changes that could happen would say it's f of x is greater than or equal to 0. Well, still, it's asking when is it greater than. But now we'd have our square brackets because we'd be including those points. Okay? But so all of that, what I just did for you guys, we got those answers. That's all stuff we did in exam 3. That was, hey, you got a picture of this graph. What's our answers? But now what we're going to be doing today is we're going to be looking at problems like this up above where they don't give you the graph. So rather than having to figure out how to graph that, I'm going to show you guys how to use the split point method, which is basically going to have us find split points. And split points are just your x-intercepts. And after you find those split points, you're going to test in this area and say, okay, is the parabola above or below? And then we'll test in this area and say, hey, is the parabola above or below? And then we'll test over here and say, hey, is the parabola above or below? And we will use this chart to help us answer those questions without having to actually graph everything. Okay? So go ahead and skip that next slide there. And we're going to go ahead and work through this first one here. I've got x squared plus x minus 12 is greater than 0. Okay? So we're asking ourselves, that's our function. And we want to know, hey, where is this function greater than 0 at? Where is this parabola above the y-axis is what we're asking. So the first step that we need to do is we need to identify Well, actually, whoa, I got ahead of myself. The first step that we need to do is we have to make sure that the left side or the right side equals 0. It doesn't matter which one's which. That's very important. Don't forget to do that step. The next step is going to involve us finding our split points. So how am I going to find my split points? Remember, they're just your x-intercepts. So all we're going to have to do is factor. So I'm just going to pretend like that's not a greater than sign and make it an equal sign. Okay, factors of 12 that subtract to give me 1. Well, I could do a 3x and a 4x. Forgot my x there. Okay, it needs to be negative 3 and a positive 4. Pull an x out, left with an x minus 3. Pull 4 out, left with an x minus 3. I get x plus 4. And I get x minus 3. So x equals a negative 4, and x equals 3. These are not my answers. This stuff right here is not my answer. Those are your split points. Those two values right there are your split points. Okay? So on your graph, those two values would be your x-intercept. Okay? So what we're going to do now, we've identified, hey, that's where it crosses that y-axis at. Now we're going to do a number line and kind of make a makeshift graph. So I'm going to make this number line here, and I'm going to say, okay, I know for a fact that it crosses at negative 4, and I know for a fact that it crosses at 3. Okay? And I'm going to put some dashes down just to kind of simulate. Okay? Remember, if we think back to what we were doing on that PowerPoint, we're saying we know that it has an x-intercept at 3 and at negative 4. And now we're going to get ready to test. And we're going to just pick a point over in this area, and we're going to test and see, is the parabola up above or is it down below there? Okay? So, when I do my test point, okay, I need to pick a test point over in this area. Points that I could pick, negative 5, negative 6, negative 7, negative 8. Any point that is to the left of negative 4. And I like to label my test points so they know what I'm doing. So where do I plug that test point into? Well, I'm going to plug it into my original equation up above. Okay? So negative 5 is going to get plugged into x squared plus x minus 12. So I've got a negative 5 squared, I forgot what it was, plus a negative 5 minus 12. And that should be greater than 0. For this problem, we're trying to figure out, is it above? Because we're asking for greater than 0. We're trying to figure out, is it above? So when I do that, I get 25 minus 5 minus 12 greater than 0. That gives me 25 minus 5 is 20. Minus 12 is 8. Is 8 greater than 0? True, it is. That means that that parabola is above in that section. Okay? Now, judging by the shape of the parabola, we should know what's going to go on in the rest of these areas. But let's check it just to make sure. What's the best number to pick between negative 4 and 3? 0. Good. 0 would be the correct one. Okay? Because it's going to be real easy to find. 0 squared plus 0 minus 12 greater than 0. All those zeros go away. You get negative 12 is greater than 0, which is false. That means that that parabola is below. It is not above in that section, which is good. That's what we wanted it to be. Okay? And then our last test point we need to pick, we could pick 4, because that's by 3. We could pick 5, 6, 7, 8, 9, 10, 11, 12. We're going to plug those in. 4 squared plus 4 minus 12 greater than 0. That gives me a 16 plus 4 minus 12 greater than 0. 16 and 4 is 20. Minus 12 is 8. Again, 8 is greater than 0, which means that that is true. Now, we have determined whether it is true or false. So how do I tell what my answer is? Well, we've got this number line up here, and it's just going to be like a normal graph. And we want to shade, I'm going to add a step in, shade above the true statements. So I am going to shade this section right here, because it was true there. And I am going to shade this section right here because it was true. Now, before I can finish this, I have to determine, do I need an open or a closed circle at -4 and 3? Well, if we look back up, do I want an open or a closed circle? Hopefully you said open because we are not including that point. So I'm going to have an open circle at -4 and an open circle at 3. Okay? So based on our graph, okay, we are running from -infinity, and we're running from -infinity all the way to -4. And I'm not including any of them. Then I'm going to go in union with, we're running from 3 all the way to infinity. Okay, and that is my answer. You have to use this chart. It specifically says on your test to solve for this, and it says to solve for it while using a chart. So you have to use that chart. Okay, if we go back through, I can pull up a picture of what this graph looks like. Okay, here's your parabola. You guys can see right here, that's our 3. Right here is our -4. And we can see true, it is above in this section. We can see true, it is above in this section here. When we were in the middle at 0, we got a false statement because it was below. Okay, we shade over the true spots, which gives us from -infinity to -4 and union with 3 to infinity. Okay, so basically when you guys are finding your split points for a quadratic, you're going to factor. Sorry for the interruptions. Just to clarify, for doing your quadratics with this, you are going to factor to find your split points, and then you just test in each area and see if the statement makes it true or false. We shade over the true section.